Hi there, let's solve this problem. 4 to the power of x plus 6 to the power of x equals to 9 to the power of x. If you think you can solve it, pause the video, then try it, and come back for the solution. Alright, welcome back. To solve this, we express in prime form, or prime number form. What do I mean by that? 4 is 2 squared, 6 is 2 times 3, and 9 is 3 squared. So I'm going to replace 4, 6, and 9 with these numbers respectively. So I'm going to have 2 squared to the power of x plus 2 times 3 to the power of x and 3 squared to the power of x. I'm going to do something very nifty here. I'm going to go 2x squared plus 2 to the power of x times 3 to the power of x equals to 3x squared. Now I can do this because it doesn't really matter. If I open this bracket, I'm still going to get the same thing. Okay, so I can switch this. There's no crime. It's from the indices rule. If I have am to the power of n, the same thing as an to the power of m, because both give you a to the power of m n. All right, so since we've understood that, we'll say let a be 2 to the power of x and b be 3 to the power of x. So here I'm going to have a squared plus ab. ab because 2 to the power of x is a, and this is b, and this is b squared. At this point, I'm going to divide through by b squared. So if I divide through by b squared, I would have a squared over b squared plus ab over b squared equals to b squared over b squared. Okay, so this is going to be a over b all squared plus a over b. So b cancels one of the squared. Then this will be 1. Now if I rearrange this, I would have a over b all squared plus a over b minus 1 equals to 0. You can see that this is a quadratic equation. So before we comment, before we continue, I want us to remember that a over b would be 2 over 3. Yeah, you remember because this is 2 raised to the power x and 3 raised to the power x, so I can bring the x. So remember this before we continue. All right, let's get rid of this. Okay, so continuing from this point, we're going to have, okay, from here rather, we say let t equals to a over b. So this becomes t squared plus t minus 1 equal to 0. Now this is quadratic like we said earlier. Let's use the quadratic formula. So minus b plus minus the square root of b squared minus 4ac all over 2a. Now from the quadratic formula, the general quadratic form of an equation is this. So your a will be the coefficient of t squared, which is 1, and your b is the coefficient of t, which is 1, and your c is the constant, which is minus 1. So we're going to plug all of this into this. So t is minus 1 plus minus 1 squared minus 4 times 1 times minus 1 all over 2 times 1. All right, so let's get rid of this again. I'm going to keep this here. So I'm going to have t equals to minus 1 plus minus the square root of, this will be 1, and this will become plus 4 because of the minus sign, so that's plus 4 all over 2. So t is minus 1 plus minus square root of 5 over 2. So quadratic equations usually have two answers. So t is minus 1 plus the square root of 5 over 2, and t is also minus 1 minus the square root of 5 over 2. So here we have to look very carefully. Remember a over b, which is actually t, if you remember. T is a over b, which is 2 over 3. So the base is positive. If we were to do this, you would see that root 5 is actually 2 point something. If you solve this, this will give you a positive value. If you solve this, this will give you a negative value. So we cannot use this. Since the base is positive, the number we're going to use has to be positive. So we're not going to use this. We're going to use this for our t. All right, so let's continue from there. So now t is minus 1 plus root 5 over 2. So t is minus 1 plus root 5 all over 2. So we're going to take it back. Like we said, t is a over b and 2 over 3x and all of that. So we're going to go, remember that 2 over 3 to the power of x is equals to a over b, which is equals to t, which is in this case minus 1 plus root 5 all over 2. Okay, so we can just crunch this into this. So you remember we're solving for x here. So since we have x and we have all these numbers, we can easily take log of both sides and find a way to get x from here. So log of this, or rather natural log of both sides. So we'll take natural log of both sides, I beg your pardon. Minus 1 plus root 5 all over 2. Okay, so if we do so, this power is going to come to the back. So we're going to have natural log of 2 over 3. Also this, minus 1 plus the root of 5 all over 2. And we close the bracket. Right, so final time, we're going to clean this. Don't worry, it's final time. And we can get rid of this too. Well, done using it. So at this point, we're going to divide both sides by this. So x would be the ln of this minus 1 plus the root of 5 all over 2 all over the ln of 2 over 3. Okay, this line doesn't look too good. Okay, better. Now, this is the same as the log of 2 base 3, or 2 over 3 rather, minus 1 plus the root of 5 all over 2. This is actually your answer. Now, we got to here, or from here to here, using the change of base rule. If I have, let's say, ln a to base b is the same thing as, let's do it this way. If I have log a to base b is the same thing as ln a over ln b, okay? So from here, got here, and from here we can go back here. So this is the rule we used to change this into this. All right, so this is your answer. Hope you found that helpful. If you did, don't forget to like, share, and subscribe. Catch you on the next one.